So variations, which you copied the block, that was part of the copy stuff. You've done direct variations and inverse variations in Algebra 1, right? This thing adds joint variations, and then it doesn't say it here, but then there's, well, it actually does right here, combinations. So you could have combinations of direct, inverse, and joint variations. If we go at the pace that I think we are, you're going to have 4 lessons in this unit. We'd end up having our quiz on the 7th and a test on the 13th. Okay. And do I got this in the right color? I do. So direct variation is y equals kx. I think of it like, the thing to understand about a direct variation is, in a direct variation, as x gets bigger, y gets bigger. As x gets smaller, y gets smaller. They vary in the same direction. Right? For inverse variation, because it's y equals k divided by x, right? The variables are x and y. K is a constant, doesn't change. If you increase the denominator of a fraction, what happens to the value of the fraction? It goes down, right? So as x gets bigger, y gets smaller. As x gets smaller, y gets bigger. So that's what I mean by they're varying inversely. And you can hear like a inverse, people talking about like an inverse relationship between quantities, and it's not in a math class. It could just be like in a, in a newspaper article. And they kind of expect that we understand that's what it means. Okay, the joint variation, which you haven't had before, is when you need 3 variables now. Z varies jointly with a product of x and y. So z equals kxy. And you could say it's like a direct variation with the product of x and y, but you just don't call it that. You call it a joint variation. And all of those have a k. K is a constant. It's called the constant of variation. Sometimes it's called a constant of proportionality. The SAT, it's kind of a big point for the SAT to say that you should understand that language. Like the book doesn't call it, they don't say something is directly proportional. They say varies directly. But directly proportional is the same thing. And SAT test is the same way. They're much more likely to say it's proportional to or directly proportional to. So keep that in mind. And I think this book doesn't use K. I've never seen any book that had anything other than K. In the SOLs, they talk about K, but this book calls it A. So we have to live with that. So write a direct variation that has -4, 8 as a solution. Okay, well here's the thing to keep in mind. If y equals kx, what does k equal? Solve for k. Minus x divided by x, right? So, x and y are variables. There's going to be an infinitely many points on this direct variation, right? So x and y, definitely they change. But the ratio y divided by x, that doesn't change. That's constant. So here we know 1 point that's on a direct variation. So with that 1 point, I should be able to calculate the k, right? What does k equal in this case? 8 over -4, so it's -2. Oh, that should have been in there. Sorry, that was not a stray mark. Okay, so now that we know what the k is, we can like update our variation. Y equals -2 times x. Now, in Algebra 1, you did direct variations, and one of the main points was, what's the 1 point on the graph of every direct variation? Look at it like this. If I compare y equals kx, what kind of a function is that? It's linear, right? X and y are to the first power. If I compare that to y equals mx plus b, what does that tell you now about the k? The k is the slope, right? And what does it tell you about the y-intercept of a direct variation? Since you don't see any plus b out here, what's the y-intercept? It's 0. It's 0. So what point on the graph does a direct variation go through? 0, 0. Every direct variation goes through the origin. And that was like one of the main things in Algebra 1. We're not dealing that much with the graphs of this here. But that is something to keep in mind. Okay, so try to write the direct variation that goes through the point 6, negative 2. So what did k equal? Negative 1/3, right? So what is the direct variation? Yep, done. Okay. Okay. Tell whether these represent direct, inverse variation, or neither. So before we could tell, we probably should solve for y, right? What is the first one going to look like when it's solved for y? Y equals 7 over x. Okay, what does that look like? Direct, inverse, or neither? It's inverse, right? With the x in the denominator. Okay, what's the next one? I mean, it's linear. It's linear for sure. What's the y-intercept? 3. Well, what's the y-intercept of a direct variation? It's 0, so it's neither. You know, it's not inverse because the x is not in the denominator, but it doesn't have a y-intercept of 0, so it's neither. Right, because of that. Okay, how about the last one? Solve for y. What do you got? Y equals 4x. Okay, so what is that? Direct. So here's your you try. Try to do the same thing with those. What'd you say about the first one? It's direct, right? I mean, if it helps, you could rewrite it. What property says that I can switch sides? No. Not reflexive, it's the other one. Symmetric, right? So this would have to be direct. Okay, how about the next one? Solve for y. 0.75 over x. That was wrong. 75 over x. That makes it inverse. Okay, and how about the last one? Neither, right? It's linear. Definitely not inverse. But it has a y-intercept of negative 5. So it's neither. Okay, easy stuff. So I always do these problems in this format, right? Now you might have learned, for example, if I go back like this, Control I. You might have learned problems like this in Algebra 1. Depends where you did it, like what book you studied, but it's something like this. Y varies directly with x. Okay. If x equals 4 when y equals 12, right, find x when y equals 24. And then because y over x is constant, you could just set it up as a proportion. You could say, okay, for the first point it's 12 over 4, and that has to be equal to whatever the y over x is for the second, so 24 over x. So you could set it up as a proportion and just cross multiply. How many remember doing something like that? Okay, so you set 12x equals 96, divide by 12, and x equals 8. Okay, I mean, you could do the same thing if it was inverse variation. Then you're going to set up not actually y over x, but x times y. That's fine for those two kind of variations, but the kinds of variations that we're really going to be doing here are more complicated than that, and really you kind of need this three-step process to do it. Right? The first step is going to be, they're going to tell you and the SAT questions are exactly the same. Right? First they're going to tell you the kind of variation that you've got. Right? So then you got to write it down. So like right away at the very beginning, x and y vary inversely. Okay, write it down. Y equals k over x. We know that that's what it means. Okay. Y equals 7 when x equals 4. So the second step is they got to give you the values of the variables at one point so you can solve for the k. So they did. Y equals 7 when x equals 4. Okay, now you can solve for k. Right? In this case, k equals 28. Okay, so we can update our formula. It was y equals k over x. Now I can say this is y equals 28 over x. And then finally I can answer a question. Find y when x equals negative 2. Y equals 28 over negative 2, which is negative 14. Like I said, we're not doing just inverse and direct variations. We'll be doing joint and combinations that are infinite. There's more combinations of variations than we could possibly ever list. It's literally infinite. So you need to have a process to do it. You won't be able to set up a proportion and cross multiply if you remember doing that. So step 1, write it down. Write down the variation. Step 2, plug in all the values so you can solve for k. Step 3, answer a question. Now sometimes in the questions, including on the SAT, sometimes it won't ask, it might just ask you to like write down the variation. What is the formula for this variation? Or it might ask you to solve for k and not ask a question at the end of that. You just have to read the question, see what they're asking for in that problem. So try to do this one. Right? Write down the formula. Substitute the values, answer your question. Okay, vary inversely. Y equals k over x. Y is negative 1 when x is 8. So what does k equal? Negative 8. So now I can say that y equals negative 8 over x. Find y when x equals 2. Okay, easy stuff. So for direct variation, we expect y over x is constant. Because if you solve for k, you get y over x. For inverse variation, if y equals k over x, then k equals x times y. It's the product that's constant. Okay, so let's see what kind of variations we've got here. All right, to check for a direct, okay, I should divide. What's 2.4 divided by negative 5? How about, say it again? Okay. What is 4 divided by negative 3? Yeah, negative 1.33. Okay, what does that tell us? It's not direct. Okay, because it's not, they have to be the same. Okay, so let's try for inverse. Inverse. Okay, what is negative 5 times 2.4? About negative 12. Okay, what is negative 3 times 4? Negative 12. How about 4 times negative 3? Negative 12. And finally, what is 8 times negative 1.5? Equals negative 12. So what does that tell us? It's an inverse, right? Since the product is constant, it's an inverse. Okay, can anybody see what this next one's going to be, just by looking at it? You know, it looks like if you divide y by x in every case, right, you're going to get negative 2, negative 2, negative 2, negative 2. So what is it? Direct. Okay, do that one. How many said direct? Inverse? Neither? It's a neither, right? It's tempting because it looks like y over x is constant until you get to the last one, right? In this case it's 3, 3, 3, and 3.25. So they're actually not constant, right? So this is a neither. Okay, the table compares the area in square millimeters of computer chip with the number C of chips that can be obtained from a silicon wafer. Write a model that gives C as a function of A. Then predict the number of chips per wafer when the area of the chip is 81 square millimeters. Okay, looking at the numbers there, do you think it's direct or inverse? Are the numbers getting bigger together, or one's getting bigger and one's getting smaller, or? It looks like the A is getting bigger, but the C is getting smaller. So which kind of variation could it be? It could be an inverse. Okay, now we got to check. If it's inverse, then we ought to be able to do the product and get a constant, right? Now, because this is a real-world problem, it actually is not going to be exactly constant. But let's see. What is 58? I'll do the A times C and right underneath. What is 58 times 4? 48. $25,984. Do you multiply? 25,984. Okay, let's try 62 times 4, 24. 26,288. I mean, it's definitely not exactly the same, but considering that it's like 26,000, it's not off by much. What's the next one? 66 times 392. Yeah, 25,872. And the last one would be 70 times 376. 26320. I mean, they're close enough to say, you know, there is an inverse relationship going on. It may not be exact, but that could be, you know, whatever. It's like a scatter plot. You know, all the points don't actually lay on exactly the same straight line. But if I was going to say this is an inverse variation, that we want C is a function of A, means you plug in A, you calculate C. What could we estimate would be the value of K? If these are all the values we got when we did X times or A times C, probably about 26,000, right? Approximately 26,000. So we'll say C equals 26,000 divided by A. Okay, so now answer a question. Predict the number of chips per wafer when the area of a chip is 81 square millimeters. What do I do with the 81? I put it in for A. 26,000 divided by 81. I'll round it to 321. Okay. So there's our word problem of the day. Okay, joint variation. Joint variation, you need three variables, right? It's like the Z varies directly with a product X, Y, but that's called a joint variation. You actually already copied that one. So again, the standard formula for these problems, right? First, they're going to give you the kind of variation that it is. Second, they're going to give you values so you can calculate K. Third, you're going to answer a question. Okay, Z varies jointly with X and Y. Z equals KXY. Z equals negative 75 when X is 3 and Y is negative 5. Negative 75 equals K times 3 times negative 5. So negative 75 equals negative 15 times K. So what does K equal? Five, right? So we can update our variation now. Z equals 5XY. And then we can go back and answer the last question. Find Z when X is 2 and Y is 6. So try that one. Okay, now it's joint variation. Z equals KXY. Z is 56. When X equals negative 6 and Y equals negative 4. So I got it wrong. Is that all right? Okay. So K equals 56 over 24, which is 7/3. So here's the updated variation. Z equals 7/3 times XY. Answer the question. Find Z when X is negative 2 and Y is 5. Negative 70 over 3. Okay, good. So the last couple slides are the combinations. So combinations are, you know, as you could see, the first one, it's direct, but it's not direct with x, it's direct with x squared, right? You would say y varies directly with x squared. Or you could say y is proportional to x squared. Right. The next one looks like z varies directly with y and inversely with x. How about the next one? What do you call that? That's a joint variation, right? That's the one we already did. Okay. The reason I put it in the list is to make sure you understand it's not the same thing as the next one, right? The next one, because the x and the y are in the denominator, you're going to have to say varies inversely with the product. We don't have a way to use the joint word with that. So we're going to say z varies inversely with the product xy. And the last one, how do you think we would say that one? Directly with x cubed and inversely with y squared. So you could see you could make up any number of combinations of these things. So this, but that's the way it works. You could say z varies jointly with x, y, and inversely with w. Right? There you go. There's another. Okay. All right, so write down those two. Last year. Right, so what did the first one look like? K times, no. Directly with W, inversely with X. How about this one? KQR over S. That's it. So that's it. And that's the homework.